We're going to learn how to solve systems of linear equations using the elimination method, or also known as the addition method. First of all, we need to decide which variable we want to eliminate for both equations, but I will cover that in a little bit. Now, let's say that you want to that you have 3x and you want to eliminate this 3x to make it equal to 0. So we have to wonder, what can we possibly add to our 3x and make it to make it 0. So this means that if you have a positive 3x, we need to add a negative 3x. They are like terms, they're opposite in sign, and therefore they will cancel each other. Now, let's say that now we have a negative 5y and we want to eliminate that one. Then in order for us to eliminate negative 5y, we need to add a positive 5y. Now, now let's try an example. So we have this system of equations, and in here we need to decide which variable we need to cancel. So in here we need to see if you add these two equations in a vertical manner, would any of these variables cancel? So if you add 3x plus 4x, that's 7x. And however, if you add the y's, you have a negative y plus y, that will eliminate. So this would be the best option, eliminate the y. So let's continue. So let me do it here on the side. You have a 3x minus y equals to 1. And we do the vertical addition as something that we have learned in the past. So we're going to do plus. And when we do this plus, these two variables eliminate each other. So we continue the vertical addition between the x's is going to be 7x equal to, we also add the constants, 1 plus 6, 7. Once we are here, we proceed to solve for x as we have regularly done in the past. So in here, we're going to divide both sides by 7. And these two numbers, of course, cancel each other. X is equals to 1. I solve for my first variable, so in here the question is you could go back to any original equation. And I like maybe the first one, it's okay. So then in here we're gonna proceed, and then I'm gonna write it again oh sorry, I said first one and I'm copying the second one. Plus, it doesn't matter, it should give us the same answer. 4 times, I got the value for the x, and the value that we got for the x is equals to 1. Once we are here, we start solving for y, so 4 times 1 plus y is equals to 6. Solve for y by subtracting 4 on both sides. Our answer will be y is equals to positive 2. So that means that this solution is a point where the x number is 1 and the y number is 2. Let's try it again. Now, if I look at these variables, so for instance, let's say that you want to look at the x's, and notice that if you add a 2x plus a 3y, nothing will eliminate them. Now, what about if you consider something else? What about if we try to add the y's? And it turns out that they are not opposite, so they will not eliminate each other. So in here, we have to decide which one should we eliminate. Should we eliminate the x or should we eliminate the y? Now, in order for you to make that decision, you really need to look at these two coefficients. You have a 2 and a 3, and you determine if you want to work with those numbers, 2 and 3. Or you have another two choices in which you could consider the y's. The y's have a 5 and a 4. So for purposes that they should be easier, the best way is to work with the smaller numbers. So here, let's make a note that you want to eliminate x. So you have a 2x and you're adding it to 3x. And remember that our goal is to get 0. Obviously, they don't get added and get to 0. Therefore, we need to find which number actually will work to eliminate. So this means that this one could be multiplied by a -3. And on the other one, this one we could multiply by a +2. And when we do this multiplication, we get a -6x plus +6x is equals to 0, which is exactly what we want. So the numbers that I use here as a -3 and the +2, I'm going to reuse them on the original equations. So let me show you how to do this. So first of all, I'm going to copy the first equation, 2x minus 5y equals to 6. My second equation, 3x minus 4y equals 9. My first equation, I said that I wanted to multiply it by -3. So here, everything gets multiplied by -3 on this side, and whatever we do in the left side, we have to do it to the right side. Also, on my second equation, we want to multiply by +2. And whatever we do on one side, we have to do it on the other side. Now, it's very important that we do not forget our distributive property. So we have to carefully do the distribution everywhere. -3 times +2x is gonna give us -6x plus 15y equals 2. On this side, we get -18. On the other one, we're gonna get from equation 2, we're gonna get +6x minus 8y, 8y equals 2, 18. Now, we're going to do the vertical addition between these two equations. And notice that these two numbers will eliminate each other. We are left with 7y equals 2. -18 plus 18 is equals to 0. Now both sides we're going to divide by 7. 0 divided by 7 is equals to 0. So I was able to get one of the variables. Now I have to go back to any of the original. Let's say I would like to pick the first one. And 2x minus 5y is equals to 6. We're going to replace this value for the y, and my y is equals to 0. And in here, this number will cancel. 2x is equals to 6. Divide both sides by 2. And in here we solve for our x, and our x is equals to 3. So in here we have a solution of our x value is 3, our y value is 0. Now let's look at this new system of equations. Now this one has a fraction, and we don't like to work with fractions. So the first thing that we should focus on is eliminate fraction. And we have discussed this how to eliminate these fractions. And the way that we remove this fraction is by multiplying using the LCD. And the LCD between 3, 1, and 1, which is the denominator, it would be 3. So we're going to multiply the first equation by 3. So let me copy the first equation. And we're going to multiply everything by positive 3. Oh, I'm sorry, I copied this number wrong. And once we have it like this, don't forget to do distribution. So the first one is going to be x plus 6y equals to negative 3. Once this equation is without any fractions, then we can line them up to see if we can actually eliminate our first equation or our second equation. And this one is x minus 6y plus 6y equals to 2. If we consider adding these two equations, nothing would eliminate. Therefore, I need to multiply one of the equations by maybe just negative 1. So negative 1 times x plus 6y equals negative 3. Actually, let me close parentheses here. Negative 1. Now my second equation will stay as it is. So this one is negative x minus 6y equal to positive 3. Now I'm going to put both of these two together. My first equation becomes negative x minus 6y equals 3. My second equation is positive x plus 6y equals to 2. When we do our vertical addition, let's see what happens. Negative x plus x cancel. Negative 6y plus 6y also cancel. So in this side, all we have left is a 0 equal to 5. For which this is not true. 0 is not equals to 5. Therefore, in this problem, there is no solution. We ended up with a false statement. One more example how to do elimination. In here I have two other equations. And again, if I look at the x's, they will not eliminate. If I look at my y's, they will not eliminate. So therefore, I need to pick which one I would like to eliminate. I actually like to eliminate the x's. One is positive 4, the other one is negative 8. That means that we can multiply only one of them by maybe 2, and that will give us positive 8 to make it opposite. So therefore, let me grab equation 1. In this equation 1, I'm going to multiply it by 2. So whatever I do on one side, I have to do it on the other side. And we're going to distribute 8x minus 14y is equals to 20. So let me put both of these equations together. 8x minus 14y is equals to 20. My second equation is negative 8x plus 14y is equals to negative 20. When I do my vertical addition, let's see what happens. These two eliminate. These two also eliminate. Therefore, on this side, I'm only left with 0 equal to 20 plus negative 20 also eliminate. So then here I'm going to get 0. 0, it is equal to 0. Therefore, this is a true statement. So in here, we're going to say that this one has infinite many solutions.